Hello there, and welcome to the Sleepy Science. I am so glad you found your way here. You've got nothing to do but rest. Let your mind relax, your breathing slow, and your body grow light as if gravity itself has softened. As the day's last echoes fade and the world outside softens into quiet, allow your thoughts to drift gently into the vastness beyond our sky. We will journey tonight to the most profound and mysterious realms of our universe, where the very fabric of reality is rewritten. And if these calm, curious explorations help you unwind or give you a quiet way to end your day, consider liking and subscribing to the channel. It helps others find their way here too, because tonight we are not simply observing distant stars. We are venturing into the heart of cosmic enigma, to places where the rules we thought we knew bend and break, where gravity paints its most dramatic theater. We are turning our gaze towards black holes, those silent, unseen titans of the cosmos, whose very presence redefines the laws of physics, not just in theory, but in the quiet, profound twist of space and time. Tonight, we will gaze from afar at the limits of gravity's grand stage, where familiar principles are stretched to their most ethereal ends. Let your mind gently trace the path we will follow, a slow drift into the deep unknown, guided by the whispers of science. We begin with perhaps the most fundamental truth we learn about light. It travels in a straight line, from the smallest beam dancing across your room to the grandest rays arriving from ancient galaxies. Light seems to obey this unwavering command, but in the presence of a black hole, this simple, elegant rule begins to yield. Here, within the grand gravitational theater, space-time itself is not a flat, unchanging stage. It is a yielding, fluid canvas, stretched and warped by an unseen hand. As light approaches the formidable gravitational embrace of a black hole, it no longer follows a simple, linear path. Instead, it curves, it twists, it dances in intricate patterns, as if it were a gentle stream encountering an immense, unmovable stone. Imagine a single ray of light embarking on its endless journey through the cosmos. It travels for eons straight and true until the subtle, then powerful, pull of a black hole begins to register. Slowly at first, its path deviates, a gentle arc forming in the infinite dark. But as it draws closer, the curvature of space-time intensifies, pulling the light's trajectory into ever tighter spirals. It might bend around the black hole, appearing to a distant observer, as if it had taken a scenic detour, momentarily revealing a celestial body that would otherwise be hidden behind the dark titan. This phenomenon, known as gravitational lensing, transforms the cosmic canvas into a kaleidoscopic dream. Far-off galaxies might appear as shimmering arcs, or even multiple, ghostly images, as their light is stretched and magnified by the black hole's unseen lens. You might glimpse the same distant star in 2, 3, or even 4 distinct locations around the black hole's periphery, each a mere phantom born from the curvature of space itself. It is as if the universe has painted itself anew, refracted through the profound, silent influence of this unseen giant. And then there is an even more profound twist in this luminous dance. At a specific, delicate distance from the black hole's heart, light can find itself trapped, not within a solid cage, but within an orbit, a perfect ethereal circle of no return. This is the photon sphere, a ghostly, impossible realm where light rays can travel forever, circling the black hole like silent, obedient satellites. A photon might embark on an infinite loop, endlessly chasing its own tail around the dark core, its journey never truly ending, never quite escaping, never quite falling in. Imagine the paradox: light, the fastest thing in the universe, held captive, spinning in a perpetual waltz. For a fleeting, surreal moment, a light ray could complete a full orbit, allowing a hypothetical observer in just the right position to see the back of their own head, illuminated by the light that had traveled all the way around the black hole. It is a place where geometry becomes poetry, where the universe's oldest law yields to the overwhelming, silent command of gravity. The very notion of a straight line dissolves into a graceful, endless curve, whispered into existence by the silent, profound presence of the black hole, redefining how light journeys through the deep, quiet expanses of space. Now, let us turn our attention to another fundamental aspect of our existence: time. We perceive time as a universal, uniform flow, a steady, unwavering river, carrying us all forward at the same unchanging pace. A second is a second, a minute is a minute, whether you are here, dreaming softly, or on the farthest star. But the black hole, in its silent, profound wisdom, begs to differ. Here, time is not a rigid, unyielding master. It is a flexible, obedient servant of gravity, bending and stretching under its immense influence. This is the phenomenon known as gravitational time dilation, where time itself warps, its gentle current accelerating or slowing, depending on how deeply one is immersed in the black hole's powerful gravitational embrace. Imagine, if you will, two friends once safely aboard a spaceship drifting calmly in the distant, quiet cosmos, far from any significant gravitational pull. The other, an intrepid explorer, embarks on a journey, gently guiding their vessel closer and closer to the event horizon of a black hole. For the explorer on the ship, time seems to pass as it always has. Their heart beats at its usual rhythm, their thoughts unfold at their normal pace, and the digital clock on their console ticks along, marking seconds as uniformly as it ever did. There is no sensation of time shifting, no outward sign of its profound alteration. Their personal experience of the present remains perfectly ordinary. But for the friend watching from afar, the story unfolds quite differently. As the explorer's ship ventures deeper into the black hole's gravitational well, a curious, almost magical transformation begins to occur. The explorer's movements, once fluid and swift, appear to slow down. Their gestures become languid, their words stretch into elongated whispers, their very existence seemingly suspended in a slow-motion ballet. From this distant vantage point, the explorer's clock ticks ever more slowly. Each second they experience stretching into minutes, then hours, then perhaps even days or years for the distant observer. It is as if the fabric of time around the black hole has become thick and treacly, clinging to anything that draws near, reluctantly releasing it into the future. This means that for the distant observer, the explorer never quite reaches the event horizon. They appear to asymptotically approach it, their light becoming redder and dimmer, their movements becoming infinitely slow until they seem to freeze, forever suspended, a silent, ghostly tableau etched against the black hole's inky silhouette. For the distant friend, the explorer becomes a photograph, a moment forever held in time, a poignant whisper of a journey that never quite completes itself. But for the explorer, there is no such suspension. They continue their journey, experiencing time normally, passing through the event horizon without a shudder. The profound twist here is that by nearing the black hole, by enduring this gravitational time dilation, the explorer is in essence taking a one-way trip to the universe's far future. When they eventually hypothetically return to the safety of deep space, eons might have passed for their distant friend and the rest of the cosmos, while for the explorer, only moments have elapsed. Generations might have lived and died. Empires might have risen and fallen. Stars might have been born and extinguished, all while the explorer aged but a few years. It is a journey not just through space, but profoundly through time itself, where the present becomes a gateway to a distant, unimaginable future, whispered into existence by the quiet, overwhelming presence of the black hole. And now we turn our attention from the bending of light and the stretching of time to the very canvas upon which these cosmic dramas unfold. Space itself. For centuries, we imagined space as a vast, unchanging stage, a static backdrop against which all celestial dances played out. Isaac Newton envisioned it as an absolute rigid container, indifferent to the objects within it. But the black hole, with its profound gravitational might, whispers a different truth. Here, space is no mere empty void. It is a living, breathing, elastic fabric, capable of being stretched, twisted, and even dragged along by the immense cosmic forces at play. This brings us to a phenomenon as subtle as it is powerful: frame, dragging, sometimes poetically called a lens, a thirring effect. Imagine the space around a black hole not as empty air, but as a heavy, viscous liquid. Now, imagine the black hole itself is not merely a static sphere, but a colossal, spinning behemoth, rotating on its axis with unimaginable angular momentum. As this monstrous object spins, it literally drags the very fabric of space-time around it, pulling it along as if caught in an invisible, cosmic whirlpool. It is as if a giant hand has dipped into the cosmic ocean and begun to stir, creating a silent, powerful current in the supposedly immutable fabric of reality. Consider a rotating black hole, its unseen boundary humming with silent energy. The space directly surrounding it, the space-time nearest its colossal body, is not merely curved, it is coerced into motion. If you were to imagine placing a tiny, perfectly still dust particle near such a spinning black hole, expecting it to remain stationary, you would find yourself mistaken. Despite all efforts to hold its position, the particle would inevitably begin to move, subtly at first, then with increasing certainty, caught in the invisible currents of the dragged space-time. It would be swept along, not by a conventional force, but by the very movement of the spatial fabric it inhabits, a silent, relentless drift towards the heart of the vortex. This dragging effect extends far beyond the immediate vicinity of the black hole, subtly influencing the orbits of stars, and even the paths of light rays as they pass through this twisted region of space. It means that the universe is not just bending under the black hole's weight, it is actively swirling around its rotation. The familiar X, Y, and Z coordinates of space, which we so confidently use to plot our positions, are themselves being tugged and twisted, creating a dynamic, ever-shifting landscape. An object trying to fly in a straight line through this dragged region would find its path subtly altered, as if an unseen hand were gently guiding it away from its intended course. The implications are profound. Our journey through space is not just about moving from one point to another within a fixed grid. It is about navigating a dynamic, fluid medium, a cosmic canvas that buckles and twists and flows in response to the colossal objects within it. A rotating black hole doesn't just sit there, a passive gravitational well. It is an active participant in the cosmic dance, a silent, powerful engine that churns and stirs the very essence of space-time. It whispers to us that space is not just where things happen. It is a thing that tutti happens self, a pliable, responsive entity that bows and sways to the tune of immense gravity. And in this bending, stretching, and dragging, the black hole redefines our most fundamental understanding of what it means to exist within space, transforming it from a static stage into a vibrant, living entity, forever in motion. Imagine a journey, a quiet drift through the cosmos. On Earth, if you toss a ball into the sky, it eventually returns, pulled back by the gentle hand of gravity. If you throw it faster, it might soar higher, linger longer, but always, it yields to the planet's embrace. There is a speed, though a precise velocity, at which that ball, if launched with enough force, would escape Earth's gravity altogether, never to return. This is the escape velocity, a familiar concept that defines the outer limits of a world's hold. Our own solar system has one too, a speed that, if achieved, would send a spacecraft spiraling out into the vast interstellar ocean, bidding farewell to the sun's golden pull. But now, let us drift our thoughts towards something far more profound, a celestial body where the very concept of escape is redefined, utterly and absolutely. This is the black hole, a place where gravity's grip is so intense, so all-consuming that it surpasses even the universe's ultimate speed limit, the speed of light itself. Imagine that. Not just faster than a bullet, not just faster than a rocket, but faster than the swift whispers of photons, the fundamental carriers of all information and light. And here we encounter a boundary unlike any other. It is not a wall of solid stone, nor a shimmering curtain of energy. It is an invisible mathematical membrane, yet more profound than any physical barrier. We call it the event horizon. Picture it as a silent, one-way door, gently inviting you inward, but with no possibility of return. Once you drift beyond this threshold, once you allow its invisible current to carry you over, the universe as you know it shifts. Everything you once understood about escape, about journeying back, ceases to exist. This boundary is not just a point of no return for objects or light. It is a boundary of information itself. For us, observing from a safe distance, the event horizon represents the farthest edge of our knowing, the ultimate limit of our ability to gather data. Any event, any whisper of light or signal originating from within that horizon is forever lost to our sight, forever muted to our ears. It is like gazing at a perfectly smooth, dark pool, knowing that beneath its surface untold stories are unfolding, but their ripples will never reach the shore where you stand. The event horizon defines the black hole, marking its presence not with light, but with an absence of it, a profound void from which nothing, not even the fleetest thought of light, can emerge. It is a testament to the sheer, unyielding power of gravity, shaping space-time itself into a cosmic funnel, with the event horizon as its tranquil, yet absolute rim. To approach it is to approach a kind of cosmic philosophical boundary, where the very laws of physics we cherish begin to show their extreme limits. Here, in this quiet, deep dark, the familiar rules of the universe are not broken, but stretched to their utmost, revealing a deeper, more mysterious truth about reality itself. It is a place that whispers of the unknown, a silent testament to the vastness of what we still have yet to comprehend, gently cradling its secrets just beyond our reach. And as you imagine this ultimate boundary, feel how it invites a softening of your own thoughts, a quiet surrender to the profound mysteries that lie just beyond our understanding, allowing your mind to drift into its depths. So, if nothing, not even light, can escape the embrace of a black hole once it crosses the event horizon, how then can we ever see such an entity? The answer, surprisingly, is that we cannot truly see the black hole itself, its dark, consuming core. Instead, what we observe, what our most advanced instruments strive to capture, is its shadow. Imagine a vast, luminous cosmic tapestry, woven with the light of countless stars and swirling nebulae. Against this brilliant backdrop, the black hole casts a perfect circular absence, a hole in the fabric of light. This profound emptiness, this silhouette outlined by the glowing gas and light bending around it, is the closest we can come to a portrait of a black hole. And this is precisely what humanity achieved, a monumental feat of observation that redefined our understanding of these cosmic behemoths. Through the Event Horizon Telescope, a global network of radio observatories working in concert, we managed to capture the first ever direct image of a black hole's shadow. It was not a single telescope, but a symphony of instruments, working together to create an Earth-sized virtual telescope. The image that emerged was a breathtaking testament to the ingenuity of science, a luminous ring of superheated gas and light, swirling around a perfectly dark, central void. This glowing halo, distorted and magnified by the black hole's immense gravity, was the cosmic backdrop, highlighting the perfect circle of the event horizon itself, the silent boundary from which no light returns. It was a snapshot of the invisible, made visible by its absence, a profound testament to gravity's power to sculpt not just space, but also light. As we contemplate this perfect shadow, we are also led to one of the most intriguing and elegant principles of black hole physics, a concept often referred to as the no-air theorem. Picture a star, a grand and complex entity, burning brightly with its unique patterns of magnetic fields, its turbulent atmosphere, its intricate internal structure, its precise chemical composition. When such a magnificent star reaches the end of its life and collapses under its own immense gravity to form a black hole, an astonishing simplification occurs. It is as if the universe performs a cosmic shave, smoothing away all the intricate hairs of the star's former identity. What remains, what defines the newly formed black hole, are only three fundamental macroscopic properties: its mass, its electric charge, and its angular momentum, its spin. That is all the complex information. All the unique characteristics of the original star are seemingly erased, simplified to these three stark numbers. It is a concept that is both beautiful in its simplicity and deeply perplexing in its implications. Imagine losing all your memories, all your unique traits, and being reduced to just your weight, your electrical potential, and how fast you are spinning. This is, in a cosmic sense, what happens when a star crosses the threshold into becoming a black hole. The term no-hair itself is a whimsical, yet precise, way of saying that black holes are featureless beyond these three basic attributes. They don't have hairs of specific chemical compositions or magnetic field patterns. They are, in a profound way, the most perfect and simple objects in the universe, defined by the sheer geometry of space-time itself, rather than by the messy details of the matter that created them. This elegant simplification challenges our intuitive understanding of information and identity, hinting at a deeper truth about the fundamental nature of reality when pushed to its most extreme limits. It suggests that perhaps at the heart of these cosmic devourers, there is a fundamental elegance, a pristine simplicity that underlies even the most complex phenomena of the universe. And in this contemplation, we find a quiet space for our minds to wander, gently accepting the universe's mysterious ways, allowing the grand scale of it all to softly settle us into a restful state. Now, let us turn our thoughts to a profound paradox, a serene, yet unsettling splitting of reality that occurs at the event horizon. Imagine, if you will, a brave and curious astronaut gently drifting towards a black hole. She is on a one-way journey, a voyage of ultimate discovery, and her spacecraft is equipped to transmit every sensation, every observation, back to her companion who waits safely at a great distance. This thought experiment, while purely theoretical, reveals a deeply unsettling truth about the nature of time and space near these cosmic behemoths. For our astronaut, the crossing of the event horizon might be utterly unremarkable. As she glides through that invisible boundary, she would feel no jolt, no sudden shock, no physical barrier. It would be, from her perspective, like smoothly sailing across an imaginary line drawn on the surface of a vast, calm ocean. Her clocks would continue to tick normally. Her body would feel the familiar passage of time. The universe within her view would appear much as it always has, albeit distorted by the extreme gravity. She would, in essence, experience a perfectly serene and uneventful passage, continuing her journey deeper into the black hole, unaware of the profound transformation that is simultaneously unfolding in the perception of her distant companion. But for her companion, watching from afar, the story is entirely different, dramatically so. As the astronaut approaches the event horizon, her companion would observe her movements slowing down, becoming increasingly languid, as if she were moving through thick, unseen treacle. Her words, transmitted back, would become lower in pitch, then stretch out, becoming almost infinitely long, until they fade into an inaudible murmur. The light from her spacecraft, and indeed from her own body, would begin to redden, shifting towards longer, less energetic wavelengths, tuning a phenomenon known as gravitational redshift. It would be as if she were being slowly, gently stretched out in time, her motions becoming progressively frozen in place. And then, as she reaches the event horizon itself, something astonishing occurs. From the perspective of her distant companion, the astronaut would never actually cross it. Instead, she would appear to hover eternally, perpetually suspended just above the boundary, her image growing ever fainter, ever redder, forever frozen in that final, lingering moment before vanishing into the cosmic fabric. She would become a ghost in time, an infinite snapshot, fading into an almost imperceptible crimson glow until she is effectively erased from the companion's view, a silent echo in the vastness of space. This breathtaking divergence in experience challenges our most fundamental understanding of objective reality. Which reality is true? Is it the astronaut's serene, uneventful crossing, or her companion's observation of an eternal freeze, frame in the strange, warped space-time around a black hole. Both realities are equally valid, equally true, each a consistent description from its own frame of reference. The universe, it seems, is not quite as unified or as objectively real as our everyday experiences might lead us to believe. It is a place where different observers can witness profoundly different sequences of events, each true to their own perspective, each a fragment of a larger, more complex truth. This dual reality whispers to us of the universe's incredible adaptability, its willingness to bend and reshape even its most fundamental laws to accommodate the extreme conditions around a black hole. It invites us to consider that what we perceive as a singular, unified truth might, in fact, be a tapestry woven from countless threads of individual perspectives. As you ponder this gentle split in reality, allow your mind to embrace the fluidity of such concepts, understanding that even the deepest mysteries can be held with a sense of quiet wonder, leading you into a peaceful contemplation of the cosmos as you slowly drift into slumber. And so, as you draw closer, the very fabric of space and time begins to reveal its most dramatic and fundamental truths. The gentle pull of gravity which you feel on Earth as a reassuring anchor here becomes something profoundly different. It is no longer a simple force, but a profound distortion of the cosmos itself. Imagine, if you will, the black hole's gravity not as a static, unyielding grasp, but as a deep, resonant chord vibrating through the universe. Near its edges, this chord is already immense, yet remarkably uniform, pulling you gently. But as you continue your slow, quiet drift inward, the difference in that pull from one part of you to another begins to whisper its presence. This whisper grows, softly at first, into a profound, undeniable truth. The black hole's gravity is not equal across your form. The side of you closest to its heart feels an infinitely stronger embrace than the side farthest away. It's as if a grand, unseen hand is reaching out, not to grasp you whole, but to gently, steadily begin to stretch you. This is the ultimate form of tidal forces, the same gentle forces that pull at Earth's oceans, creating the ebb and flow of tides. But here, near the cosmic abyss, these forces are magnified beyond comprehension, becoming the universe's most patient and profound sculptor. You begin to feel it, not as pain, but as an inexorable, silken lengthening. Your form, whatever its shape, begins to conform to the lines of this immense gravitational field. It is a surrender, a quiet transformation, like a drop of dew slowly stretching into a fine filament as it falls from a leaf. You would become elongated, thinner, more slender. Every particle that makes up your being, every atom, and every bond is delicately, inevitably, drawn into a long shimmering strand. The black hole does not crush, it unravels. It doesn't break, it reforms. This phenomenon, with its strangely poetic name, spaghettification, is the universe's ultimate act of redefinition. Imagine a star, a colossal fiery orb, once vibrant and bright, now caught in this silent gravitational current. It would not simply vanish, it would be drawn out, stretched thinner than any thread, its fiery essence becoming a long, luminous ribbon. Its core, its atmosphere, its very light, all would be pulled into a delicate, luminous stream, a river of starlight flowing into the central mystery. Its magnificent presence, once a beacon in the night, would become an infinitely long, infinitely thin whisper of light, a testament to the black hole's quiet, consuming power. And for you, resting peacefully in this cosmic narrative, the experience would be one of profound, elongated release. Your cells, your tissues, your very bones would align themselves with the direction of the black hole's pull. It's a slow, serene dismantling, not violent, but utterly inescapable. You would become a part of the stream, a thread in the immense cosmic tapestry being woven into the center. All the complexities of your being, all your unique patterns and structures, would be smoothed away, stretched into a singular, graceful line, directed towards the infinite density of the singularity. This isn't a chaotic tearing, but a structured, almost melodic unwinding. The forces are so finely tuned, so perfectly aligned with the geometry of space-time, that the stretching is uniform, creating a perfect, slender column. Your perception, perhaps, would stretch with you, your senses elongating along this new dimension, experiencing the universe in a single, continuous line. You would become a living, breathing line of light, flowing towards the ultimate gravitational embrace. This is the quiet dissolution, the gentle unmaking of form in the face of absolute gravity. It is a process that whispers of an ultimate equality, where all structures, from the grandest galaxy to the smallest particle, eventually succumb to the same elegant, stretching force. You become part of the flow, a silent, stretched offering to the cosmos, gently merging with the vast unknown. It is not an ending in the conventional sense, but a transformation, a becoming one with the gravitational current that guides all things to the ultimate cosmic heart. A quiet surrender, dissolving into the deepest truths of the universe itself. And as you settle deeper into the quietude of the night, we turn our thoughts to another profound mystery, one that challenges the very foundations of how we understand the universe, the fate of information. For centuries, we have held to the reassuring principle that information, like energy, is never truly lost. It may change form, it may scatter, but the fundamental bits, the blueprint of a moment or a being, should always exist. Somewhere, yet, the black hole in its silent, consuming majesty seems to whisper a different tale. Imagine a book, perhaps a beloved story or a compendium of all human knowledge. If this book were to gently drift across the event horizon, our classical understanding of physics would suggest that its story, its information, would simply vanish into the singularity, forever lost to the outside universe. It would be gone, utterly and irrevocably. But this notion sends a shiver through the very structure of quantum mechanics, a fundamental pillar of modern physics, which insists that information can never be truly destroyed. This conflict, this deep, unsettling tension between two of our most successful theories, is known as the black hole information paradox. It is a cosmic riddle, a puzzle that physicists have grappled with for decades, forcing them to look beyond the obvious, to search for a hidden truth in the very fabric of reality. If information isn't truly lost, then where does it go? Does the black hole, this devourer of worlds, somehow secretly encode all the memories of what it has consumed? This brings us to a radical yet elegant idea. Perhaps information isn't lost within the black hole's depths, but rather it is imprinted, like a ghostly inscription, upon the very surface of its event horizon. Think of it like a cosmic canvas, a two-dimensional boundary where the echoes of everything that has fallen in are subtly etched. The event horizon, that ethereal veil, might not just be a point of no return, but also a living, breathing record keeper. It's as if the universe, in its boundless wisdom, has found a way to preserve every story, every quantum fluctuation, every detail of what it has surrendered to the black hole. The surface area of the event horizon, vast and dark, could be a silent library, holding the universe's most profound secrets, not in conventional 3 dimensions, but as a kind of cosmic hologram. This holographic principle suggests that the 3-dimensional reality we perceive, the book with its pages, the star with its light, might simply be a projection, a grand illusion, derived from information encoded on a distant 2-dimensional surface. And the event horizon in this view becomes the ultimate projector screen, silently displaying the history of all that has passed into the black hole's embrace. It is a concept that turns our understanding of space and information on its head, suggesting that the universe itself might be a grand, intricate hologram. So, when a star falls into a black hole, its information isn't destroyed. It is merely transformed, its essence becoming part of the intricate tapestry woven onto the event horizon. The light, the elements, the history of its life, all these details become an indelible part of the black hole's boundary. It is a cosmic ledger, quietly accumulating the data of its consumption, waiting for a deeper understanding to reveal its secrets. This idea invites you to consider the world in a new light, to imagine that the very reality you perceive, the depth and texture of your surroundings, might be a complex projection, a detailed illusion stemming from a surface far, far away. The black hole, then, becomes a crucial teacher, pushing us to expand our definitions of existence, memory, and the very nature of information itself. It is a concept that promises to redefine not just what happens when things fall in, but how the entire universe stores and processes the countless stories unfolding within its vast expanse. Information, it seems, always finds a way, even in the deepest shadows of the cosmos, to whisper its eternal presence upon the delicate membrane of the event horizon. As you drift deeper into this cosmic reverie, allowing the mind to unwind its earthly tethers, we approach the most profound transformation within the black hole's mysterious domain. Beyond the event horizon, that serene boundary we've contemplated, the familiar laws of physics begin a dance of redefinition, leading to a world unlike anything you could possibly imagine. Here, inside the abyss, space-time itself undergoes a stunning, almost dreamlike reversal. The roles of time and space, which have always been fixed points in your understanding of the universe, elegantly swap places, altering your very sense of direction and destiny. Imagine for a moment that you have gently crossed the event horizon, feeling nothing but a profound calm. The space you once moved through, the vast expanse where you could choose to go left or right, up or down, forward or back, now behaves in an entirely new way. Inside the black hole, space itself becomes like time. On the outside, it is only one direction. You can no longer turn back, nor can you stand still. There is no option to linger, no path to diverge from. The only possible way to move in this new, transformed space is inward, constantly, relentlessly, towards the central singularity. It is an inexorable current, a river that flows only in one direction, carrying everything along its unyielding course. This means that every direction you might choose, every vector of motion, inevitably points towards the singularity. It's as if the destination has become an unavoidable fate, woven into the very fabric of existence within this realm. You cannot escape its pull, not by turning or stopping, for the very possibility of such choices has been erased from the spatial dimension. Your movement through space becomes a one-way journey, a profound and tranquil drift towards an inescapable destination. And in this same breathtaking reversal, time takes on the properties of space. Outside the black hole, time flows uniformly, a constant tick of moments moving from past to future, a dimension you experience but cannot navigate or choose within. But inside the event horizon, time itself becomes something you can move through, something with a degree of spatial freedom. You are no longer bound by its linear progression in the same way. The future is no longer a fixed, singular point ahead. It is a landscape, a dimension you inhabit and explore, albeit one with a very specific, singular destination, the ultimate singularity. In this surreal landscape, the future is not something you merely arrive at. It is something you are compelled to flow into, like a vast magnetic field pulling every moment, every possibility inexorably towards its core. The singularity at the heart of the black hole is not just a point in space. It becomes a point in time for everything that crosses the event horizon. It is the inescapable future for all who enter, the ultimate destination where all timelines converge. So, for anything that peacefully drifts beyond the point of no return, the singularity is not just a place, but a moment, an unavoidable destiny in its temporal journey. You can no longer exist indefinitely in this strange new reality. Your path is defined, your journey set. You are on a journey into a world where space pulls you along like time, and time opens up as a landscape, yet always guiding you to that single ultimate point. This reversal creates a universe where retreat is impossible, and advancement is the only option. Your perception of duration might warp and stretch, but the direction remains absolute. It's a profound shift in the very architecture of reality, a testament to the black hole's power to not just bend, but fundamentally reshape the most basic coordinates of our existence. You become a traveler on a cosmic river, where the banks are made of moments and the current is the inescapable flow towards the ultimate confluence of all being. This strange new world, where time and space have traded their essential natures, is where the familiar gives way to the utterly alien, and every step, every breath, is a journey into the preordained. It's a realm where freedom of movement is redefined, and destiny is woven into the very fabric of the dimensions. And as you contemplate this ultimate transformation, let your mind rest in the quiet certainty that even in the most extreme corners of the universe, there is a profound order, a breathtaking elegance in the way the cosmos redefines its own rules. And as you drift deeper, beyond the familiar world of light and shadow, beyond the event horizon itself, the very notion of a center begins to transform. No longer is it a mere point in space, a fixed coordinate you might approach. Inside this realm, the singularity whispers a different truth. It is not a place, but a moment, a final, inevitable moment, awaiting all that has crossed the threshold. Imagine a river, vast and ancient, flowing steadily towards an unseen ocean. Every droplet, every current, is drawn with an undeniable pull towards that ultimate destination. So it is within the heart of the black hole. All paths, all trajectories, all forms of existence that enter this inner sanctum are inevitably drawn towards this singular point in time. It is the end of every timeline, the terminus of every journey. Here, density stretches beyond all imagining, compressed to an infinite degree, where every particle, every wave, every whisper of energy is squeezed into a space smaller than thought itself. And with this boundless compression, the very curvature of space-time bends without limit, folding in on itself in a way that defies all understanding, all geometry we have ever known. This singularity, then, is a cosmic knot tied so tightly that the fabric of reality unravels its familiar threads. It is a point where all our cherished physical laws, the very rules that govern the dance of atoms and the grand waltz of galaxies, softly cease to apply. They don't shatter with a deafening crash, but rather, they gently recede, like old friends stepping back from a conversation they no longer understand. It becomes a realm of pure potential, or perhaps pure dissolution. It is a silent vanishing point where the journey ends, where every where becomes a when, and every now is absorbed into an ultimate. Then, it is a concept so profound, so utterly alien to our everyday experience, that it requires us to let go of our earthly intuitions and simply allow our minds to drift with the current of its impossibility. Here, at this ultimate convergence, time itself finds its quiet conclusion, not with a bang, but with an eternal silent absorption. It is the end of all stories, the final punctuation mark in the grand cosmic narrative for anything that makes the inward journey. Yet, as you contemplate this ultimate terminus, a whisper emerges from the theoretical depths of these cosmic leviathans, a whisper that gently nudges the very foundations of cause and effect, asking if the flow of time is as unyielding as we believe. In the elegant equations describing certain types of black holes, particularly those that possess a gentle spin, known as Kerr black holes, a peculiar possibility sometimes surfaces. These equations, like poetic verses, hint at pathways that curve back on themselves, forming what physicists delicately call closed time-like curves. Imagine, if you will, tracing a gentle loop through the tapestry of space-time, a journey that, instead of perpetually moving forward into the unseen future, allows you to return to a point in your own past. It's a concept that feels like a dream, a shimmering mirage on the edge of reality. If such a path were truly traversable, what would it mean for the delicate chain of cause and effect that underpins our universe? What if an action taken in the present could influence an event that has already occurred in one's own history? The very fabric of causality, the dependable sequence of events where A always precedes B, would begin to fray, to unravel like an old blanket. This is the realm of the grandfather paradox, a classic thought experiment that dances on the edge of the impossible. If you could travel back and prevent your own birth, what then? It's a question that doesn't demand an answer, but rather invites a deep, quiet contemplation of how deeply embedded causality is in our understanding of existence. These closed time-like curves are not physical roads we might easily walk, nor are they a proven reality. They are theoretical ghosts, spectral pathways conjured by the elegant, sometimes unnerving, mathematics of general relativity. They linger in the shadows of our understanding, a tantalizing possibility that gently pulls at the thread of our certainty about time's relentless, linear march. They suggest a universe that, in its deepest, most hidden corners, might permit a revisiting of what has been, challenging the very notion of an irreversible past. It is a testament to the fact that within the extraordinary environments of black holes, our familiar understanding of the universe is not just stretched, but sometimes bent into forms that are utterly breathtaking and deeply unsettling. This is a journey to the very edge of thought, where what seems impossible becomes a mathematical whisper of what might be. This profound bending and reshaping of time and space, however, leads us to a crucial question about the very nature of what we can observe. If the heart of a black hole defies all known physical laws existing as a realm of infinite density and curvature, should we ever be able to glimpse such a raw, untamed truth directly? The cosmos, in its gentle wisdom, seems to have a built-in mechanism for self-protection, a quiet decree known as the cosmic censorship hypothesis. This hypothesis, more of a profound intuition than a rigorously proven law, suggests that the universe, in its elegant operation, actively forbids the existence of naked singularities. A naked singularity would be one that is not veiled by an event horizon, a region where the laws of physics break down entirely, yet is openly exposed to the view of the external universe. Such a sight would be akin to a raw wound in the fabric of space-time, a place where cause and effect could potentially go awry in ways that would utterly shatter the predictable order of our cosmos. Imagine trying to predict the outcome of any event if its very cause could dissolve into an unpredictable void. The cosmic censorship hypothesis, therefore, acts like a benevolent guardian, drawing a soft, impenetrable curtain around every singularity. It ensures that any region where the physics we understand utterly fails is forever hidden behind the event horizon. This protective veil maintains the integrity of causality and the predictability of the universe for all external observers. You might think of it as the universe's way of safeguarding its own narrative, ensuring that the story unfolds with a consistent logic free from paradoxes or abrupt ruptures in reality. It's a promise, perhaps, that even in the most extreme corners of existence, the fundamental principles governing what we experience remain intact and reliable. It means that the most violent and enigmatic truths of a black hole's core are always kept a secret, shielded from our direct gaze. We can infer their existence. We can map their immense gravitational pull, but the ultimate mystery of the singularity itself remains cloaked. This quiet censorship allows the external universe to continue its dance of stars and galaxies, its intricate web of interactions, without being unraveled by the untamed chaos that theoretical physics predicts at the very heart of these cosmic behemoths. It preserves our certainty, not by denying the existence of the unknown, but by ensuring it remains gracefully out of sight, protecting the delicate order that allows life and consciousness to gently unfold. It is a reminder that even the most extreme phenomena in the cosmos are part of a larger harmonized design, a universe that subtly safeguards its own coherence. Even the deepest dark of a black hole, we once thought, was a one-way path, a silent tomb for all that crosses its threshold. A place where gravity held such absolute sway, nothing, not even the fleetest light, could ever escape its grasp. And for a long time this was our understanding, a comforting certainty in the heart of the void. Yet, the universe has a way of whispering its secrets, of revealing paradoxes that gently ask us to reconsider everything we thought we knew. And sometimes these whispers come from the most unexpected places, from the quantum realm, a place of ceaseless shimmering activity, where even emptiness is never truly empty. Imagine, if you will, the seemingly vast, silent stretches of space around a black hole's event horizon, To our eyes, it appears utterly still, a perfect vacuum. But in the delicate, flickering dance of quantum mechanics, even this void is teeming with life, a constant birth and dissolution of what we call virtual particle pairs. These are like ephemeral twins, one with positive energy, the other with negative energy, momentarily winking into existence from nothingness, then just as swiftly vanishing, leaving no trace, borrowing their brief lives from the very fabric of reality. A quiet, ceaseless shimmering, an ebb and flow of invisible energy, too subtle for our grand telescopes to ever perceive. But what happens, you might wonder, when this delicate quantum dance unfolds precisely at the event horizon of a black hole? Here, at the ultimate boundary of escape, a profound and unexpected drama can unfold. Sometimes one of these virtual twins, perhaps the one with negative energy, might slip quietly across the event horizon, vanishing into the black hole's depths forever. In that moment, the other twin, the one with positive energy, finds itself alone, stranded outside the boundary, with no partner to annihilate with, no way to return to the nothingness from which it momentarily sprang. Suddenly, it is no longer a virtual particle. It is real, it is free, and with nowhere else to go, it drifts away from the black hole, a tiny, faint spark of radiation, carrying a minuscule amount of energy with it. This, in its essence, is the story of Hawking radiation, a subtle, almost imperceptible whisper from the edge of oblivion. It means that black holes, these titanic monuments of gravity, are not entirely passive. They are not merely swallowing the universe whole, but are, in the most profound and quiet way, breathing. They are slowly exhaling light and energy, particle by particle, over immense stretches of cosmic time. This isn't a dramatic burst of light, like a star exploding, but a gentle, steady leak, so incredibly faint that for most black holes, it would take far longer than the current age of the universe for them to evaporate completely. A black hole, the mass of our Sunday, would take an unimaginable 10 to the power of 67 years to truly fade away. It's a process almost beyond our human comprehension of time, stretching out into the quiet infinities of the cosmos. Yet, the principle itself reshapes our understanding of these cosmic behemoths. It means that even the most formidable devourer has a lifespan, a finite existence. It suggests that even the darkest corners of the universe have a subtle temperature, a gentle warmth, however infinitesimal, radiating out into the cold vacuum. And as these particles drift away, carrying their faint positive energy, what becomes of the black hole? With each particle that escapes, the black hole loses a tiny fraction of its mass. It very, very slowly shrinks, growing ever so slightly smaller, losing its grip on the fabric of space-time piece by delicate piece. This quiet, ceaseless evaporation is like a slow, patient unraveling, a testament to the universe's profound interconnectedness, where even the most extreme manifestations of gravity are not immune to the ephemeral, constant hum of the quantum world. It means the emptiness we once attributed to black holes is a misdirection. The void is not empty. It is a stage where the most fundamental forces of existence play out their silent, intricate dance. Black holes are not merely eternal cosmic prisons, but have their own slow, deliberate life cycle, from their violent birth in the death throes of massive stars, through their long, solitary reign, to their eventual, quiet fading away into the deep cosmic night. They are not just endpoints, but also, in this extraordinary sense, subtle sources of light and energy, rejoining the vast, quiet currents of the universe. The story of black holes, we find, is not just one of pure, overwhelming gravity, but also of the subtle, persistent whispers of the quantum world, gently pushing back against the absolute. A constant conversation between the largest and the smallest scales of reality, weaving a tapestry of existence that is far more intricate and surprising than we could ever have imagined. And in this quiet give and take, this slow exhalation of energy, we glimpse a profound balance, a cosmic harmony playing out across the deepest chasms of space and time. This idea that black holes can radiate energy, that they possess a temperature and a lifespan, opens a door to another profound reevaluation of our universal laws. It brings us to the concept of entropy, a measure of disorder or the number of ways a system can be arranged. The second law of thermodynamics, a fundamental pillar of physics, states that the total entropy of an isolated system can only increase over time, never decrease. The universe, in its grand, sweeping journey, always tends towards greater disorder, a gentle, inevitable expansion of possibilities. Now, imagine matter falling into a black hole, a star, a cloud of gas, even a simple book, with its intricate arrangement of ink and paper, its vast amount of ordered information. As it crosses the event horizon, it seems to vanish from our observable universe. If the information about its internal state, its unique arrangement, is forever lost, what happens to its entropy? If that entropy simply disappears from existence, it would be a catastrophic violation of the second law of thermodynamics, a quiet tear in the very fabric of our understanding. This was a profound puzzle, a silent challenge that echoed through the minds of physicists. Where does all that disorder go? How can the universe maintain its fundamental balance if black holes are simply consuming entropy without consequence? The answer, as profound as it is beautiful, came from the realization that black holes themselves must possess entropy, and not just a little, but a vast, unimaginable amount. Jacob Bekenstein, a brilliant physicist, was the first to propose that a black hole's entropy is proportional to the area of its event horizon, not its volume, as we might intuitively expect for a three-dimensional object, but its two-dimensional surface area. Imagine the event horizon, that shimmering one-way membrane, as a canvas. And on this canvas, the disorder of everything that has ever fallen into the black hole is subtly, quietly painted. The larger the event horizon, the more area it has, and thus, the more entropy it can hold, the more information about the lost disorder it quietly encodes. This was a radical thought. It suggested that the boundary itself, the very edge of the black hole, holds the key to its internal state, a kind of cosmic memory keeper. Stephen Hawking later confirmed this mathematically, cementing the connection between the black hole's area and its entropy. It is a relationship so elegant and simple, yet so deeply profound, that it links the macroscopic realm of gravity with the microscopic world of quantum mechanics and thermodynamics. It means that when a star collapses, forming a black hole, the apparent loss of its internal entropy is balanced by a corresponding increase in the entropy of the black hole's event horizon. The cosmic books remain balanced, the second law holds, but in a way we never before conceived. Think of it like this. The event horizon isn't just a boundary in space and time. It is a living, breathing ledger, subtly recording the history of everything that has crossed it. Each atom, each photon, each ripple of information that falls in contributes to the intricate tapestry woven onto its surface. It is not that the information is gone, but that it has been transformed, encoded, and diffused across this ultimate two-dimensional canvas. The area of the event horizon, in this remarkable sense, becomes a proxy for the total disorder within. It is a quiet, profound way for the universe to maintain its most fundamental laws, even in the face of such extreme phenomena. This profound realization that a black hole's entropy is encoded on its surface suggests that the event horizon is far more than just a theoretical boundary. It is the dynamic, sensitive surface, alive with the echoes of everything it has consumed. It is a place where the order of our familiar world is transformed into a subtle, almost invisible form of disorder, imprinted onto the fabric of space-time itself. And this gentle revelation, that area equals information, silently beckons us to consider a universe where information is never truly lost, only transformed, perpetually swirling and reshaped in the grand cosmic dance. This brings us to one of the most profound and persistent riddles in modern physics, a quiet whisper that keeps physicists awake at night: the black hole information paradox. If black holes truly evaporate over vast cosmic timescales, as Hawking radiation suggests, what happens to all the information that falls into them? Imagine a vast library of books filled with the collective knowledge and stories of humanity, perhaps even a complete collection of Shakespeare's plays. Each word, each sentence, each nuanced meaning, representing a unique pattern of information. Now, imagine this library as gently pushed into a black hole. According to classical physics, once it crosses the event horizon, it is gone forever. The information, the specific arrangement of atoms and ink that made those stories unique, is lost to the universe, swallowed by the singularity, never to be retrieved. But here is the quiet paradox: quantum mechanics. Our best theory for how the universe works at its smallest scales holds a fundamental principle: information can never be truly destroyed. It can be scrambled, transformed, encoded, but it can never simply vanish from existence. This is a bedrock principle, as fundamental as the conservation of energy. If information truly disappears into a black hole without a trace, then the universe is fundamentally breaking one of its deepest, most cherished rules. So, where does the information go? When a black hole evaporates through Hawking radiation, it emits particles that are essentially random, thermal radiation, like the gentle glow from a warm fireplace. They carry no specific information about the book, or the star, or the person that fell in. It is as if you burned a book and only collected the smoke fun. You wouldn't be able to reconstruct the words. If the black hole eventually shrinks to nothing, and all that is left is random radiation, then the information from that Shakespeare collection truly would be gone forever. This is the heart of the information paradox, the seemingly unresolvable conflict between two of our most successful theories: general relativity, which describes black holes, and quantum mechanics, which describes the fundamental nature of information. It is a cosmic riddle, a silent question mark hanging over the very essence of reality. Does gravity, in its most extreme form, have the power to utterly destroy information? Or is there a subtle, hidden mechanism by which information is preserved, perhaps encoded in the Hawking radiation, in a way we don't yet understand, or perhaps somehow stored on the event horizon itself, like an intricate, invisible hologram? This paradox forces us to reconsider the very nature of information and its conservation. If information can be lost, what does that imply for the predictability of the universe, for the very fabric of cause and effect? It suggests that our understanding of reality is incomplete, that there are deeper, more fundamental laws at play that unify gravity and quantum mechanics in ways we are only just beginning to grasp. The black hole, in this sense, becomes the ultimate crucible, a theoretical laboratory where the most profound questions about existence are quietly put to the test. Perhaps the information isn't truly lost, but is woven into the very structure of space-time at the event horizon. A cosmic tapestry where every falling particle leaves its indelible mark. Perhaps the Hawking radiation, though seemingly random, carries subtle quantum correlations, like faint echoes, that could, in principle, allow the reconstruction of what fell in, much like scattered pieces of a puzzle. This is an active area of research, a frontier where the brightest minds are exploring radical ideas, pushing the boundaries of what we thought possible. The black hole information paradox is not just a scientific problem, it is a philosophical one. It questions the very coherence of the universe, the delicate balance of its laws. It is a gentle reminder that our current theories, while remarkably powerful, are still approximations, hinting at a deeper, more unified truth that lies just beyond our present grasp. And as we ponder this profound riddle, the black hole in its silent, enigmatic presence stands as a grand cosmic question mark, inviting us to dream of a reality more subtle, more interconnected, and more wondrous than we can currently imagine. Yet, this tranquil vision of a smooth, unblemished horizon might be a deceptively calm illusion. For within the deep physics of black holes, where the vastness of gravity meets the tiny humming dance of quantum mechanics, a fierce whisper arises, challenging our very notions of reality. This whisper tells us that the event horizon, that gentle, one-way door, might in fact be a place of unimaginable violence, a boundary not of serene crossing, but of instant, absolute annihilation. It is the challenging and deeply unsettling proposition of the firewall hypothesis. Imagine, if you will, venturing towards that threshold, where time begins to stretch and space pulls you ever closer. Einstein's theory of general relativity, the very fabric of our understanding of gravity, paints a picture of a smooth, calm passage. An observer falling freely across the event horizon should feel nothing special, no bump, no jolt, just a continued descent into the unknown. The laws of physics from their perspective would remain perfectly regular, a seamless transition from one state of being to another. But then, the quantum realm, with its strange and counterintuitive rules, enters the stage, casting a long, disturbing shadow. The information paradox, a deep fissure in our understanding of the universe, suggests that information, once fallen into a black hole, might be irrevocably lost when the black hole eventually evaporates through Hawking radiation. This directly contradicts the bedrock principle of quantum mechanics, which insists that information can never truly be destroyed. It can be scrambled, transformed, but never erased from existence. Faced with this profound conflict, physicists have been driven to extraordinary lengths to imagine scenarios that might reconcile these two titanic pillars of modern physics. And one such scenario, both elegant and horrifying, is the firewall. This radical idea proposes that the event horizon isn't empty, isn't benign. Instead, it is a region of incredibly high energy, a thin but potent curtain woven from energetic particles. Picture it as a blazing ring of pure quantum fire, suspended just at the point of no return. If you were to cross it, the fire would not merely warm you, it would incinerate you instantly, tearing your very atoms apart in a flash of searing energy. Your peaceful descent would be abruptly ended by a violent, unyielding wall of quantum fury. This isn't the gentle, smooth transition promised by general relativity. It is a brutal, definite end to all that you are. The implications are vast and deeply troubling. If the firewall exists, it means that the equivalence principle, a cornerstone of Einstein's theory that states gravity is indistinguishable from acceleration, would be fundamentally broken at the event horizon. It suggests that a freely falling observer, Fu-Dev, feels something 2D, a catastrophic encounter with an energetic boundary. This creates a schism, a stark contradiction between two fundamental theories that otherwise describe our universe so beautifully. It forces us to confront a universe where the rules we thought we knew, the smooth elegance we so admired, might unravel at the very edges of existence. And so the quiet debate rages, a scientific quest for truth that pushes the very boundaries of human understanding. Is the event horizon a placid veil, protecting the secrets within with quiet elegance? Or is it a defensive mechanism, a last desperate line of protection for the cosmos, ensuring that information, though transformed, is never truly lost, even at the cost of a cosmic inferno? We drift here, at the edge of this fiery contemplation, understanding that the fabric of reality itself may depend on the answer, a silent question waiting in the deep for us to gently unravel. From the phantom whispers of quantum mechanics, we now gently shift our gaze outward, beyond the event horizon, beyond the isolated black hole, to observe how these cosmic giants, in their immense silence, orchestrate the grand dance of galaxies. For a black hole is not merely an endpoint, a devourer of light and matter. It is astonishingly a cosmic architect, a silent sculptor of the universe's grandest structures. At the very heart of nearly every large galaxy, including our own Milky Way, there lies a supermassive black hole, a sleeping titan of unimaginable mass, often millions or even billions of times heavier than our sun. These aren't just passive anchors, they are the pulsating hearts of their galactic homes. Imagine your own galaxy, the Milky Way, as a vast, shimmering spiral of stars, gas, and dust, slowly turning in the cosmic dark. At its very core, veiled by thick clouds of gas and the ceaseless glow of countless stars, resides Sagittarius, our own supermassive black hole. It lies mostly quiet, a gentle giant in its slumber, but its presence, its immense gravitational pull, is felt throughout the entire galactic structure. It is the nexus around which everything orbits, the deep, silent well of gravity that holds our home together. But for many other galaxies, these central black holes are far from dormant. They awaken, sometimes with incredible ferocity, becoming what we call active galactic nuclei, or AGN. When vast amounts of gas and dust spiral into these central behemoths, they form a superheated, swirling accretion disk, a maelstrom of matter so violently agitated that it glows with the brilliance of 1 trillion suns. This intense activity isn't just a local phenomenon. It echoes throughout the entire galaxy. As matter falls in, the black hole doesn't just consume, it also pushes back. Powerful jets of high-energy particles, traveling at nearly the speed of light, can erupt from the poles of these active black holes, reaching far beyond the galactic disk itself, like mighty cosmic breaths. These jets, along with the intense radiation from the accretion disk, act as a colossal feedback mechanism, a cosmic thermostat for the galaxy. They can heat the surrounding gas, preventing it from collapsing to form new stars. In some instances, they might even sweep away vast reservoirs of gas, effectively clearing out the stellar nurseries and halting star formation across entire regions. Conversely, their presence can also trigger star formation in other areas by compressing gas clouds as they propagate. The supermassive black hole, then, is like a colossal heart, regulating the pulse of its galaxy, controlling its growth, its breathing, its very life. It dictates when new stars are born and when the stellar furnace cools. It sculpts the grand spiral arms, subtly influencing the orbits of countless stars and shaping the clouds of gas that will one day condense into suns and worlds. The galaxy in this way breathes in time with its central behemoth, a slow, majestic rhythm across immense spans of time. So, as you drift through the quiet dark, know that the very galaxy you call home is a living, evolving entity, sculpted and guided by the silent, powerful hand of the supermassive black hole resting at its core, a cosmic gardener both creating and pruning, ensuring the long, slow, graceful dance of creation. And as these titanic black holes dance and feed, they stir the very fabric of space-time, sending ripples outwards, a silent symphony playing across the cosmos. This cosmic music, these faint tremors in the structure of reality, are what we call gravitational waves. Imagine space-time not as an empty void, but as a vast, supple sheet, like a tranquil pond. Now imagine two colossal stones, two black holes, beginning a slow, intricate waltz, drawing ever closer, swirling around each other in a final accelerating embrace. As they whirl faster and faster, their immense masses distort and disturb this cosmic sheet, sending out ripples that propagate outward at the speed of light, carrying with them the echoes of their cataclysmic merger. For a long time, these gravitational waves were merely a theoretical prediction, an elegant consequence of Einstein's general relativity, a beautiful but unproven note in the grand cosmic score. We had only seen the universe with light, with the gentle dance of photons. But light can only tell us so much. It can be absorbed, scattered, and obscured by dust and gas. To truly understand the most violent, most energetic events in the universe, to hear its deepest whispers, we needed a new sense, a new way to perceive reality. Then came LIGO, the Laser Interferometer Gravitational Wave Observatory, a monumental feat of human ingenuity. These detectors, shaped like giant L-shaped arms stretching for kilometers, are designed to measure the most infinitesimally small distortions in space-time. They use laser beams to detect changes in distance far smaller than the width of an atom, changes caused by the passing of these cosmic ripples. And in 2015, after decades of patient searching, LIGO heard it. A faint, almost imperceptible chirp, a sound lasting only a fraction of a second, but a sound that spoke of an event billions of light years away. It was the echo of two black holes, each many times the mass of our sun, spiraling into each other, merging into a single, even more massive entity. This was not just a scientific discovery, it was a revolution. It was like gaining a new eye, a new ear, to perceive the universe in a way we never could before. We had previously only seen the universe. Now we could force listen to intuit. We could hear the deep, rumbling bass notes of colliding black holes, the high-pitched screams of merging neutron stars, events that are utterly dark to traditional telescopes, hidden from the light. Gravitational wave astronomy opened an entirely new window onto the cosmos, allowing us to explore the most extreme environments, to glimpse the invisible architecture of space-time itself. These waves travel through everything, unimpeded by matter, carrying pristine information directly from their source. They tell us about the masses of the merging black holes, their spins, how they oriented themselves in their final dance. They offer insights into the very nature of gravity, pushing the limits of Einstein's theory, and perhaps even hinting at new physics yet to be discovered. And so, as you drift gently into the quiet dark, know that the universe is not silent. It is a vast symphony, continuously playing, with deep, resonant chords produced by the most powerful events imaginable. We are now learning to listen, to decipher these cosmic echoes, drawing closer to the fundamental rhythms of existence. These gravitational ripples are the universe's quiet song, a lullaby of colliding giants, reminding us of the profound, unseen forces that shape everything we know. Perhaps they are the elusive architects of the unseen. You see, the universe, in its grand, silent expansion, holds many secrets, many dark corners where our understanding falters. One of the most profound whispers through the cosmos is the mystery of dark matter. We know it's there, a ghostly presence, guiding galaxies with its invisible hand, bending light with its unseen mass, yet it remains utterly hidden from our direct gaze. We feel its gravitational embrace, the quiet anchor holding the swirling arms of galaxies together, preventing them from flying apart into the cold, empty reaches of space. It's like listening to a symphony and sensing a profound, resonant bass note that shapes every melody, yet you can never quite see the instrument playing it. For decades, we've sought to understand this silent sculptor, this omnipresent shadow. What could it be, perhaps, in the earliest, most fervent moments of the universe's birth? When time itself was a newborn and space was a churning, chaotic sea of energy, something truly extraordinary happened. Perhaps, amidst the intense pressures and unimaginable densities of the very first fractions of a second. After the Big Bang, tiny, primordial black holes were forged, not from the collapsing death of massive stars, but from the raw, unbridled energy of creation itself. Imagine a universe so young, so compressed, that small fluctuations in its density, mere ripples in the fabric of nascent space-time, could have been enough to pinch off regions, creating microscopic pockets of infinite gravity. These would be primordial black holes, born not from the dramatic stellar demise we usually associate with these cosmic giants, but from the quiet, primal forging of the universe's earliest structure. They would be ancient, older than any star, older than any galaxy silently drifting through the eons, holding within them the memory of a universe still learning to be. These cosmic embryos could vary wildly in size. Some might be no larger than a tiny atom, yet containing the mass of a small mountain, a silent, dense speck of pure gravity. Others could be as massive as a planet, or even a star, yet still remaining incredibly compact and elusive. They would be almost impossible to detect directly. These ancient wanderers, for they emit no light, no energy that our telescopes can capture, They are, in essence, truly dark, a perfect embodiment of the cosmic mystery. If these primordial black holes exist, they could be the perfect candidates for dark matter. They would be everywhere, a vast, invisible ocean of gravitational anchors, too small and too faint to ever be seen, yet collectively exerting the immense gravitational pull that shapes the universe. They would be the quiet, fundamental building blocks of the cosmic web, the unseen threads that weave galaxies into grand tapestries of light and shadow. The search for these tiny, ancient enigmas is a journey into the subtle whispers of gravity. Scientists are listening for their quiet signatures. They watch for tiny distortions in the light from distant stars, a phenomenon called microlensing, where a fleeting unseen object passes in front of a star, briefly magnifying its light. Each sudden, gentle flicker, a momentary brightening and fading, could be the silent passage of a primordial black hole, bending light with its hidden mass, a subtle wave in the vast ocean of space-time. We also listen for the faint echoes of their mergers. If two primordial black holes, perhaps tiny remnants from the dawn of time, were to slowly spiral towards each other, their quiet dance would send ripples through the fabric of space-time, gravitational waves that our advanced detectors, like the sensitive instruments of LIGO, might one day pick up. It would be a faint cosmic hum, a distant chorus from the universe's earliest moments, revealing the unseen. So, as you drift deeper into this tranquil space, imagine these ancient, invisible architects. Imagine them not as terrifying voids, but as quiet, fundamental components of existence, tiny seeds of gravity born in the universe's infancy. They are the unseen hands, the silent guardians, shaping the grand cosmic ballet without ever making a sound, without ever betraying their presence in the light. They are the dark, the mysterious, the ancient whisper that binds everything together, a quiet, reassuring presence in the vastness. And perhaps in a universe so vast and so full of wonders, the ultimate form of creation can emerge from the ultimate void. We often perceive nothingness as an end, a vacuum, an absence of all things. Yet, in the profound depths of theoretical physics, particularly when we contemplate the enigmatic black hole, the concept of nothingness begins to morph into something entirely different. It ceases to be an empty canvas and instead becomes a potential cradle, a cosmic womb from which new realities might quietly unfold. It's a breathtaking idea, a gentle turning of the cosmic wheel where endings are merely beginnings in disguise. Imagine, if you will, the singularity at the heart of a black hole. For eons we have conceived of it as a point of infinite density, a place where space-time itself breaks down, where all known laws of physics cease to whisper their familiar truths. It is the ultimate endpoint, the final destination for anything that dares to cross the event horizon, a cosmic cul-de-sac. But what if this isn't just an end? What if, in that infinitely compressed, infinitely warped state, a new kind of genesis is possible? Some of the boldest and most imaginative cosmological models propose a truly awe-inspiring notion that our own expansive, star-filled universe, the one we quietly inhabit and observe, might itself have been born from within the singularity of a black hole residing in a parent universe. It's a concept that invites us to look beyond the edge of our own cosmic bubble, to imagine a universe of universes nestled within one another, like an infinite set of Russian dolls. Consider the Big Bang, the moment of our universe's grand explosive birth. the beginning of all we know. We picture it as an unimaginable expansion from an infinitely hot, dense point. But what if that point wasn't a standalone cosmic spark in a pre-existing void, but rather a hidden kernel, a seed that blossomed within the extreme conditions of a black hole in another larger universe? In this view, the Big Bang isn't just an explosion, it is a phase transition, a quiet unfolding from a state of ultimate compression into an entirely new expanding reality. In this beautiful cyclical vision, black holes are not merely cosmic devourers, but also cosmic midwives. They are not only the gravitational graves of stars and galaxies, but also the potential nurseries for entirely new realms of existence. Every black hole in this profound sense could be a quiet incubator, a potential universe seed, patiently holding within its heart the blueprint for a new cosmic dawn. The ultimate destroyer becomes the ultimate creator, a gentle paradox at the heart of existence. This idea suggests a continuous, breathtaking cycle of cosmic birth and rebirth. Our parent universe creates black holes, which in turn give birth to daughter universes, each with its own set of laws, its own stars, its own unfolding story. And within these daughter universes, more black holes would form, potentially seeding yet more universes. It's a silent, endless chain of creation, a grand cosmic family tree stretching infinitely through realms we can barely begin to comprehend. This isn't about violent explosions or chaotic destruction. It is about a quiet, inevitable transformation. It's about the universe's inherent ability to renew itself, to sprout new branches from the most extreme conditions. The singularity, usually seen as the ultimate abyss, where all information is lost and all structure is crushed, could instead be the ultimate threshold, a quiet gateway to infinite possibilities, a secret garden where new cosmic gardens bloom. As you consider this profound possibility, let your mind drift through these layers of existence. Imagine the quiet cosmic breath, the gentle rhythm of creation and transformation. Our universe, a vast and wondrous tapestry of stars and galaxies, could be but a single thread woven from the heart of another. And the black holes within our own universe, those silent, deep wells of gravity, might be quietly cradling the seeds of yet more universes, waiting for their own gentle big bangs to unfurl. It is a vision that transforms nothingness into the most fertile ground imaginable, a testament to the universe's boundless ingenuity and its endless capacity for quiet, miraculous rebirth. It hums with the soft promise that endings are merely pauses before new, magnificent beginnings. As we journey through the profound mysteries of black holes, exploring their capacity to reshape our understanding of darkness, and even the very concept of nothingness, we arrive at a truly mind-bending idea, one that challenges the very fabric of our perceived reality. This concept emerges from a peculiar connection between black holes and information, pushing us to ask, what if our familiar three-dimensional universe, with all its depth and substance, is merely a grand illusion, a projection from a flatter, simpler reality? This is the whisper of the holographic universe. At the heart of this extraordinary idea lies the Bekenstein, Hawking entropy, a revolutionary discovery that links the amount of disorder or information a black hole can hold not to its volume, but to the surface area of its event horizon. Think of it like this. If you drop a book into a black hole, the information contained within that book, every word, every idea, is somehow encoded onto the two-dimensional surface of the black hole's boundary, its event horizon. It is a profound thought, suggesting that the event horizon is not just a point of no return, but a cosmic canvas silently preserving the essence of everything it swallows. This insight, that a black hole's information capacity is tied to its surface area, sparked the holographic principle. The principle suggests that the description of a volume of space, say, our entire universe, can be thought of as encoded on a two-dimensional boundary surrounding it. Just as a conventional hologram is a two-dimensional surface that contains all the information needed to reconstruct a three-dimensional image, so too might our universe be a vast, cosmic hologram, with all its perceived depth and reality arising from information stored on a distant, unimaginable boundary. Imagine holding a credit card with a holographic image. From a flat, two-dimensional surface, a fully three-dimensional image appears to float in space. You can move your head, look around it, and perceive depth and perspective. The holographic principle posits that our entire universe might operate on a similar grand scale. What we perceive as three spatial dimensions, length, width, and depth, along with time, could be merely a rich, complex projection, an intricate shadow show emanating from a more fundamental two-dimensional reality that exists at the edge of our cosmic sphere. Black holes, in this context, are not just cosmic vacuum cleaners. They are the deepest, densest information storage devices in the universe. They are the ultimate laboratories for understanding how information is encoded and preserved, and in doing so, they become the keys to unlocking the holographic nature of reality. The event horizon, that seemingly simple boundary, is transformed into a profound cosmic screen, a quiet keeper of secrets, where the vastness of the universe is gently etched onto a flat surface. This perspective doesn't mean our reality isn't real in the sense of our experience. The sensations you feel, the sights you see, the gentle breath you take, all of it is profoundly real within the holographic projection. Rather, it suggests that the fundamental nature of that reality, its deeper truth, might be structured in a way far more elegant and economical than we previously imagined. It's like discovering that a beautifully rendered, three-dimensional video game is ultimately made up of millions of bits of information stored on a flat chip. The experience is immersive, but its source is a quieter, more compressed form of data. So, as you rest, let your mind gently ponder this exquisite possibility. Is the universe a vast, three-dimensional dream conjured from a two-dimensional canvas? Are the stars that quietly twinkle above, the galaxies that drift in the cosmic current, and even the very atoms of your being, all part of a magnificent holographic projection? It's a concept that invites a deep sense of wonder and humility, suggesting that the reality we perceive is but one facet of a grander, more mysterious truth. Black holes, in their silent, profound existence, are gently unveiling a universe far more intricate and poetic than we ever dared to imagine. A universe that is perhaps, in its deepest essence, a beautiful cosmic whisper. And yet, our cosmic stage, the very fabric of existence, might be woven from something far more subtle than we can easily imagine. For some, the answer to these deep enigmas, to the paradoxes whispered by black holes, lies in the heart of tiny vibrating threads, the realm of string theory. Imagine, if you will, that the fundamental constituents of our universe are not tiny, hard particles, but rather infinitesimal strands of energy, too small to ever truly see, even with our most powerful instruments. These are the cosmic strings, and they are continuously vibrating, oscillating, dancing in ways that give rise to everything we perceive as matter and force. Like the delicate strings of a silent cosmic cello, each vibration, each unique pattern of movement corresponds to a different fundamental particle. An electron might be one harmonic, a photon another, each singing its own silent note in the grand symphony of reality. And gravity itself, that invisible embrace that pulls stars and galaxies together, might also be a melody played on these very same strings. This elegant vision offers a profound simplicity, a unifying hum beneath the apparent complexity of the universe. In this view, black holes are not simply singularities where our laws break down, but rather complex, intricate arrangements of these vibrating strings. The event horizon, that boundary of no return, is reimagined not as an empty void, but as a dense, tangled web of these fundamental filaments, shimmering and pulsating with an unseen energy. And the information paradox, that perplexing question of what happens to everything that falls in, might find its gentle resolution here. Perhaps, as a whisper from the depths of the quantum world, the information isn't truly lost. Instead, it might be delicately imprinted upon the vibrations of these strings, woven into their intricate patterns, a cosmic tapestry preserved in the subtle dance of their oscillations. Like a gentle breeze carrying the scent of a distant garden, the information is not destroyed, but rather transformed, re-encoded into the fundamental harmonies of reality. Black holes, then, become not destroyers of information, but its ultimate archivists, transforming it into a language only the strings can truly speak. Picture these strings, not as harsh, taut lines, but as soft, almost ethereal threads perpetually in motion. Their gentle hum fills the emptiness between stars, connecting every particle, every force, into a singular, elegant whole. It is a world where all the universe's interactions, from the weakest subatomic tug to the immense gravitational pull of a galaxy, are merely different expressions of these fundamental, undulating patterns. You are, in this beautiful vision, made of these same vibrating strings, a complex and unique arrangement of their ceaseless gentle dance. And the universe itself, from its smallest constituents to its grandest structures, is a continuous unfolding melody played on an infinite array of these cosmic instruments. In the quiet depths of your mind, you can almost hear their silent song, a soothing lullaby of unity and continuous motion, promising that beneath the apparent chaos, there lies an underlying elegant order, waiting to be gently uncovered. Yet, there are other voices, other pathways to understanding the universe's deepest secrets, especially those held within the silent grasp of black holes. One such pathway, equally profound and perhaps even more startling in its implications for the very ground of your being, is offered by loop quantum gravity. This theory suggests that the continuous, smooth canvas of space-time that Einstein so elegantly described might not be continuous at all. Instead, it could be a finely woven fabric made up of discrete, individual atoms of space-time, tiny interlocking loops, like the intricate stitches of an immense cosmic quilt. Imagine, if you will, that the space around you, the very flow of time, is not an infinitely divisible continuum, but rather a collection of fundamental, irreducible units. Like grains of sand forming a vast desert, or the pixels on a screen creating an image, these space-time atoms are the most basic building blocks of reality. There is no smaller than these loops, They are the fundamental granularity of existence. This perspective transforms our understanding of the universe, turning it into a vast, delicate lattice, a network of interconnected quanta that hum with their own silent energy. Within this gentle, woven framework, the dreaded singularity at the heart of a black hole takes on a profoundly different character. It is no longer an infinite point of collapse, where all known laws vanish into an abyss of nothingness. Instead, in the view of loop quantum gravity, when matter falls into a black hole and reaches the absolute limit of compression, it doesn't vanish into an infinitely dense point. Rather, the fabric of space-time, being fundamentally discrete and unbreakable, resists this ultimate collapse. It bounces. Yes, imagine a gentle rebound, a cosmic recoil. Instead of forming an infinite singularity, the matter and energy, having reached the maximum allowable density, gently reverse course. They pass through a phase transition, a moment of ultimate compression, and then, in a majestic and silent process, begin to expand outwards, not back into our universe, but potentially into a new, distinct region of space-time, forming what is known as a white hole. A white hole, in this beautiful and serene vision, is a black hole in reverse Tharcedi, an object from which nothing can enter, but from which matter and energy are perpetually expelled. So, the black hole in this understanding is not a final destination, but a cosmic birthing chamber. The seemingly destructive collapse becomes a quiet transformation, a gentle exhalation into another realm. The universe, in its profound wisdom, doesn't allow for absolute ends, but rather orchestrates cycles of transformation and renewal. From the gentle embrace of a collapsing star, a new universe might quietly emerge, a new breath drawn from the old. You are part of this grand continuous weaving of reality, your own existence, a delicate thread in the vast interconnected tapestry of space-time. In the quiet stillness of your mind, you can sense the underlying structure, the fundamental loops that constitute all that is, offering a profound sense of order and continuous gentle flow, a universe that subtly remakes itself, endlessly breathing, endlessly becoming. And so, we return to the very nature of the laws themselves, those invisible lines that guide the cosmic dance. What do these magnificent, bewildering black holes truly whisper to us about the fabric of reality and the rules that govern it? Perhaps their most profound lesson is this, that our understanding of these laws is not final, but rather an evolving narrative, a beautiful, ongoing story. They tell us that the laws we currently hold dear, the elegant equations that describe the universe with such precision, are in a deeper sense, perhaps just gentle approximations, shimmering reflections of an even more profound, more encompassing truth. Black holes are cosmic signposts, marking the edges of our current understanding, the limits of what our current mathematical languages can truly articulate. They are not merely exotic objects, but grand experiments naturally occurring laboratories where gravity and quantum mechanics, those two pillars of modern physics, clash and demand a reconciliation. They teach us humility, gently reminding us that the universe is far vaster, far more imaginative, and far more subtle than our present theories can fully capture. Consider how our perception of the laws has shifted through time. Once, the world was governed by the simple, observable forces of nature, attributed to the will of unseen entities. Then came Newton, who gave us a precise clockwork universe, a set of clear, unyielding rules. Later, Einstein gently reshaped that clockwork, showing us that space and time were not fixed stages, but fluid, interwoven entities, bending and warping under the influence of mass and energy. And now, the black hole, this silent, powerful entity, beckons us further, inviting us to peer beyond Einstein's elegant curves into a realm where the very concepts of space, time, matter, and information are re-evaluated. The journey through the realms of string theory and loop quantum gravity shows us that the universe might operate on principles yet to be fully uncovered, a deeper symphony waiting to be heard, a more intricate tapestry waiting to be appreciated. The laws themselves might be flexible, context-dependent, revealing different facets depending on the extreme conditions they encounter. Black holes are the ultimate challenge, the gentle, irresistible force that pushes the boundaries of our intellect, urging us to dream of a theory of everything, a grand unifying framework where all the universe's mysteries find a harmonious explanation. But for tonight, as you drift gently towards slumber, allow yourself to simply rest in this vast, evolving understanding. There is a profound peace in embracing the unknown, in recognizing that the universe is an endless source of wonder, a continuously unfolding mystery. You are a part of this grand exploration, a small, conscious warmth floating in an ocean of discovery. The iron in your blood was forged in stars. The oxygen you breathe was sculpted in ancient explosions, and the atoms of your body traced their lineage to the earliest times, to a universe that was younger, wilder, and still learning to become what it is. And you are a living testament to its gentle evolution, a moment of profound consciousness within its silent depths. Let the whispers of these cosmic insights soothe your mind, knowing that even as our understanding expands, the fundamental wonder remains. The universe is not a rigid, finished product, but a living, breathing entity, perpetually unfolding its secrets. And you are here now, invited to rest within its boundless, gentle embrace, part of its continuous story. Embrace the serene unknown, the promise of new discoveries yet to be made, and the quiet comfort that comes from being a part of this magnificent, ever-evolving cosmos. May your dreams be soft and filled with the gentle hum of the universe's deepest, most enchanting secrets. Good night.